In this video, I am going to make a battery out of wires, coins with copper in them, aluminum foil, and cardboard. So here's my design for the battery. It consists of a coin at the bottom, cardboard on top of the coin, and aluminum foil on top of the cardboard. I'm going to repeat this process for the entire battery. Also included in the original design is tape to hold the wires into place and alligator clips that are supposed to be added onto these wires to connect to the probes. I couldn't find any clear tape at the moment, so I also wrote down that I needed to add on plastic wrap. So now, to assemble the battery, we need to get our pennies, which we already have, and we don't really need to work with those that much for now. And now what we need to do is cut out the cardboard to the shape of the coin. So we simply draw around the coin, and then we'll cut out the cardboard that's shaped like the coin with scissors, and we'll also follow the same process for our aluminum foil. And we're going to soak the cardboard that we cut out into vinegar. And as you can see here, this is what we have now. Now I forgot to add on a copper coin, as you can see here. I did that and then added on the wires. So we connected it with the crocodile clips, and I was not able to get that good of a reading, and I had to pinch the coins together, and I only got about half a volt. Now I also had realized that quite a few people in tutorials had used their fingers to pinch together this setup. So I had to figure out how I can have a stronger grip with the tape. Another issue was the amount of copper in the pennies, and I was able to fix this by using quarters, and I was able to actually get a good reading. The quarters have a higher volume, so then you can have a bit more pressure on them if you use the same amount of tape. I also used Gorilla Tape, which kind of helped, but mainly it was using quarters, as they have more copper in them. So I decided that for my second design, I would have the new coins as quarters. So I then tried connecting two of these cells to the voltmeter with the positive and negative ends, and I was not able to get that good of a reading considering how many coins I was using. I used about 30 coins. And as you can see right here, I was only able to get a tiny half volt, which isn't that good. So then I decided to go back to the drawing board and to just hook up two coins. Two coins were enough to get me 0.25 of a volt, and that amount shows that I would be able to get a good reading of certainly more than half a volt with that amount of coins if I hooked up numerous cells. And what I decided then was to work on the pressure, because I can't really work with the tape because the tape has to be there in order to make it a legit battery that stays together. So then I had to work with a new design with alligator clips hooked onto the battery, and I also used a smaller amount of coins when I decided to take my own battery together. And as you can see here, this is my final durable design, where I have a very strong setup with the alligator clips being on very strong. And I was able to get a good half volt off of this, and it was only 5 coins. So in theory, you would be able to hook up these and get quite a bit of voltage. So going with tons of smaller cells certainly will help, as it makes it easier to get more pressure with the alligator clips wired and the wires on your battery. Now that we're done discussing the design, let's discuss a bit of the chemistry behind this. So the stoichiometry can be seen when we have to ensure that the aluminum, cardboard, and vinegar are all in the proper place. This shows the law of mass conservation, as the matter cannot be created or destroyed at random locations for the reaction to work properly. Ions are taken advantage of with the end result, as they are the core from which we are able to use electricity. The acidic copper and the basic aluminum, in this case, correspond with how the electrons flow. The vinegar was acidic and helped carry the charge in the correct direction. What is shown in this image is a general layout showing how the battery consists of copper, vinegar, and aluminum, and the vinegar acts as the electrolyte and acid. The copper and the aluminum are the cathode and anode, respectively. The cells are all added together to maximize the charge.